Hi everyone, welcome back to Virtual School Physics is Fun. This is Puan Liao. Okay, today's topic is resonance. Now, in the topic of damping, we learned that an oscillating system will not continue to oscillate forever because there is loss of energy to the surrounding, and it is called damping. Can you still remember? Okay, just imagine an oscillating pendulum or a swing. Okay, a swing. If I want the swing to continue to swing, what should you do? Of course, we push the swing on and off, right? So when you push the swing, you are supplying an external force. Okay, so you're supplying an external force. And if the external force has the same natural frequency as the oscillating system, the system that is receiving the energy will oscillate with maximum amplitude. All right, and this is called resonance. Let's look at this definition again. Yeah, so resonance will occur when a system is forced to oscillate at its natural frequency by an external force. The external force has the same frequency as the oscillating system. The oscillating system, the resonating system, will oscillate at maximum amplitude. So it receives maximum energy from the external force. Okay, all right, look at this video. Yeah, so we have A, B, C, D, E. We have 5 pendulum paper cup, pendulum made of paper cup, and we have one pendulum here which is made of pendulum bob. Okay, so we are going to oscillate only this pendulum, and the rest we are not touching it. You see what happened. Okay, so this guy, you oscillate this pendulum bob, and you can see that the rest of the pendulum starts to oscillate. Because why? They receive energy from this external force, right? And one particular pendulum is oscillating at the highest amplitude, oscillating at the highest amplitude. So that means this pendulum is said to be resonating. Why this particular pendulum play? Because this pendulum has the same natural frequency as this pendulum bob, right? So they have the same natural frequency, so this receive the maximum energy. Okay, let's look at the next slide. Yeah. Okay, this is called Barton's pendulum. So this pendulum X is the driver, said to be driver, because we only oscillate this pendulum, whereas the other pendulum A, B, C, D, E, we are not touching it. So when pendulum X is being pushed, so it will supply energy to pendulum A, B, C, D, E. Okay, but so A, B, C, D, E will start to oscillate, but only one particular pendulum that is oscillating at the highest amplitude. And we have watched the video just now. It was C that was oscillating at the highest amplitude. Because why? Because C receives the maximum energy from X. Why C receives the maximum energy? Simply because C and X have the same natural frequency. So if they have the same natural frequency, C is receiving the maximum amplitude, and therefore it is oscillating at maximum amplitude. Why C and X have the same natural frequency? What affects the frequency of an oscillating system? Yes, it is the length, right? So X and C have got the same length, therefore they have the same natural frequency. So C receive the maximum energy and start to oscillate at maximum amplitude. So we say pendulum C is resonating. All right. Okay, let's look at this example here. See, I'm
How
rubbing
auto splash out?
When I rub,
You see the
water
water splash out?
splatters up.
Yeah, it shows that water molecule is vibrating at very high.
Okay, so as I rub the bowl, okay, I cause the bowl, the molecule of the bowl to oscillate. Alright, so I am the force, the external force. So this external force, if it is of the same natural frequency as the frequency of the water molecules, the water molecule receives maximum energy and starts to resonate. So when they start to resonate, they oscillate at the at maximum amplitude. So you can see the water start to jump up, yeah, jump up very high. So we say that the water is resonating.
If I hit one of these forks, like I'm going to hit this one, but I'm not going to touch that one. And you see this one sitting over here by itself. And I hit that one. Watch. Whoa! Do you see that? That one wasn't connected to this one. It's not touching it at all. They're sitting on feet. They don't have any connection at all. But if I hit this one, the other one picks it up. Now, if I did it the other way around, if I hit this one, then that one picks it up. Now, if I do that with one of these different forks, if I use...
So here you see that when Grandpa John hits at one tuning fork, sound is heard, right? So because this tuning fork vibrates, so sound is produced. Then when he grabbed this tuning fork and remove it, we still continue to hear the same sound. So where does the sound come from? It must have come from this pendulum, this tuning fork. Okay, but we never hit this tuning fork. How come that it vibrates and produce sound? Oh, it's because both of these tuning fork, they have the same length, so that's why they have the same natural frequency. So when he hits this tuning fork, this is a external force. So it will supply energy to this tuning fork, and this tuning fork will start to resonate. It receives the maximum energy, it starts to oscillate with maximum amplitude and produce sound, right? Produce sound. So when you take this pendulum away, this second tuning fork continue to produce the same sound. So this is resonance.
I've got two tuning forks here.
Okay, look at this.
Resonance cart. The weights on these sticks each have their own natural frequency. The red weight has a high natural frequency, the yellow weight has a medium natural frequency, and the blue weight has a low natural frequency. When Katie vibrates the cart with a high frequency, the red weight has the largest amplitude. When she matches the natural frequency of the blue weight by vibrating the cart slowly, the blue weight has the largest amplitude. When she matches the natural frequency of the yellow weight resonates with her shaking and has the largest amplitude.
Okay, so you see that if it matches the natural frequency, it will oscillate at maximum amplitude. So this is resonance. Okay, so example of resonance in everyday life, there are many. So this is the popular one where a brass singer to sing, or the glass break. Why? Because she supplied the external force to cause the glass to oscillate, and if it is of the same natural frequency, it will oscillate with maximum amplitude. The glass is not strong enough to withstand the vibration, it breaks. Because this is an advertisement, okay? There are many examples of resonance in our daily life, so you can check out from the internet, okay? Now, some of these effects are positive and some of them are negative. What are the positive effects? First one, A tuner in a radio or television enables us to select the channel we want. When we tune in to a radio, the circuit in the tuner is adjusted until resonance is achieved at the frequency transmitted by a particular station that we have selected. Hence, a strong electrical signal is produced and the station is received loud and clear. Second one, the loudness of a wind musical instrument like trumpet and flute is the result of resonance of the air. The negative effects, a bridge may collapse when amplitude of its vibration increases because of resonance. The action of the wind can cause the bridge to vibrate with a large amplitude as a result of resonance. So if the structure of the bridge is not strong enough, so the bridge will break and collapse. The loud explosion can cause a glass window to break, just like the example that we see. Oh yeah, this is the second one. The high-pitched note of an opera singer can cause a thin glass to shatter. Yeah, just now the video, the advertisement video that we have watched. Okay, the last one, excessive noise from a moving vehicle can cause vibration. Okay, the vibration of an engine can cause loose part to resonate. Okay, so these are the positive and negative effects of resonance. All right, just now we say musical instrument, the good effect. So loudness of a wind musical instrument like trumpet and flute is the result of resonance of the air. So when we shape the mouth, our mouth, and we blow into this trumpet or flute, the air is resonating and loud sound is produced. All right, the negative effect. So the wind is the external force that causes the bridge to resonate. Okay, resonate. So if the structure of the bridge is not strong, it will break. Yeah. So like what happened in 1940, Tacoma Bridge collapsed. So you can watch this video if you surf online. Yeah.
The remains of the world.
Okay, that's all about resonance. We will continue again some other time. Thank you. Bye.